Hey there, class. Mr. Prusky here. Hope you're having a good day so far. Today we're continuing with 1.3, and we're using the midpoint formula and distance formulas today. So, yeah, let's get into it here. We have a warm-up here, which is segment addition postulate. If you recall, the segment addition postulate means that the parts of the entire segment add to the whole segment. So we're trying to find UV in this problem. So why don't you guys go ahead and see how you do. All right, so we have UV. We don't know what that is. Let's call that X. And we have 45 is VW. We're looking for UV. So we can do this two different ways. Remember, we have two different methods. We can do the setup where the parts add to the whole. So the parts would be X plus 45 equals 56. And then we subtract 45. We get X equals 11, or UV equals 11. Or, that's method one. Or method two is literally, we can just subtract 56 minus 45. If you're comfortable with that and see that, that is totally fine. So 11 works in both ways there. Okay, so we have some definitions and stuff to fill in here. So the midpoint is the point that divides a line segment into two congruent segments. What kind of segments? Congruent segments. The midpoint, an easier definition, is that it's the middle of a line segment. Okay? All right, segment bisector is any kind of shape, a point, ray, line segment, or plane that intersects, intersects the segment at its midpoint. At its what? Midpoint. All right. And a segment bisector divides at what? It divides a line segment exactly in two. Exactly in two. Okay, so here's, I don't know. This is kind of, these boxes right here, like these, I don't really like that much. I'm going to add up, they're in the notes for some of these, but we're going to do some easier versions of this too, okay? So the formula, we have a little rhyme to help us remember how to find the midpoint of a line. And it's right here. It is midpoint, what do you do? Add them together and divide by 2. Okay, so it's midpoint, what do you do? Add them together and divide by 2. Another way to say this is that the midpoint is the average of the 2 points. Average of the 2 points, okay? All right. So we have this formula right here. So the x, m, y, m, or the little m's in the corner are they are labels. Okay, so x sub m, y sub m is basically the midpoint. So this is going to be x sub m, and this is going to be y sub m. So what I like to do is this. I like to go x sub m. There's two formulas here. Equals x1 plus x2 over 2, and y sub m equals y sub 1 plus y sub 2 all over 2. Okay? And it says where your answers in order paired just like 2, -5 like the original points were. Okay? All right. Let's get going here. So we have find segment lengths. Example 1. It says find RS. So RS is this length right here. We know that these tick marks right here in the middle mean that RT is congruent to TS, and we know that RT is 21.7, so we're looking for that whole length there. Well, what can we do here, do you think? Well, if RT is 21.7 and TS is congruent to that, what's TS going to be equal to? 21.7, okay? So the whole length, how do we find the whole length? What are we going to do? Well, we're going to add them up, or multiply by 2. We're going to do 21.7. Oops. 21.7. I'm going to do times 2. Okay? You can do 21.7 plus 21.7, which equals 43.4, and that's going to be your answer. Okay, why don't you guys try checkpoint 1 on your own now? It's kind of a similar idea. We have some fractions here that'll be fun to talk about, but give it a try, see how you do. Okay, find AB. Well, what do we know in this problem? We're looking for AB as the entire length again. We know that this is, that AC is congruent to CB, and that AC is 2 1/4. What's CB going to be if AC is 2 1/4? It's also going to be 2 1/4, okay? If we add those together to get the whole, AB is going to be equal to, it's going to be 4 2/4, right? Actually, let me write that and fix this here. So we have 2 1/4 plus 2 1/4, which equals, add the whole numbers, which is 4, add the fractions, which is 2/4, right? 1/4 plus 1/4, that's 2/4. And then 2/4 reduces to what? It is 1/2. Alrighty. And there we go. Okay, now, these next couple problems are very similar to what we were doing before in 1.2, but it's a little bit different because we know that there's a midpoint here, okay? So let's think this through a little bit. All right, so this point C is the midpoint of BD, segment BD. Find the length of BC. So we're looking for BC. We know that, what do these tick marks mean? BC is congruent to what? To CD, okay? So you're either gonna, for these problems, in 1.2 we added them up and set them equal to the entire length. This time we don't know the entire length, we just know that BC is congruent to CD. So what do you guys think we're gonna do with the 3x minus 2 and the 2x plus 3 if they're congruent? What symbol do we use for congruence usually? Well, yeah, if they're congruent, their lengths are gonna be equal. So we're gonna do 3x minus 2 equals 2x plus 3. Okay, and be careful. These are basically the two options you're going to have. Is you're either going to set them up, add them equal to the total, you're going to do segment addition postulate, or you're going to just set them equal and solve. But from here, you guys should be able to solve this. Go ahead and see if you remember how to solve this, and we'll go through it in a second. All right, so we're going to get all the x's to one side, and I'm going to subtract 2x from both sides. So I get x minus 2 equals 3. Or yeah, now we need to get all the, get x by itself. How do we do that? We're going to add 2. So we get x equals 5. Are we done? Are we looking for x, or what are we looking for? I forgot the box what we're looking for. We're looking for the length of BC. So BC was what? BC was 3x minus 2. So I'm going to take this 5, I'm going to plug it in for what? Plug it in for x. If x equals 5, we can plug it in for x. So we have BC equals 3 times 5 minus 2. Then we get, we keep going, equals 3 times 5 is what? 15, and what's 15 minus 2? It is 13, so our answer should be 13. And also, if they're equal, you don't need to write this down if you don't want to, but let's plug into CD as well. It was 2x plus 3, right? X was still 5. What's 2 times 5? That's 10. What's 10 plus 3? It's 13. So you can see that these are both 13, so that means we were doing it right, because both of these are 13. And that's how it should be. Okay, why don't you guys go ahead and try checkpoint 2 on your own now. Pause the video, see how you do. All right, so we have point K is the midpoint of JL. Find the length of KL. Are these congruent, or are they going to add up to something? They are congruent. There's tick marks here. So we're going to set them equal or add them up. We're going to set them equal. So what we're going to do is we're going to do, actually, you know what? I told you the wrong thing here. We're going to change this to 10. I told you the wrong thing. I'm going to try to fix it on the lesson 2. We're going to change this to 10 to make it a little bit easier to work with, okay? So we have 10 minus 3x equals 2x plus 5. Okay, they're equal because it's because the k is the midpoint and these are congruent. So now we need to solve for x. How do we do that? I'm going to add 3x. So we get 10 equals 5x. 2x plus 3x is 5x plus 5. Now what do we do? Minus 5. And you get 5 equals 5x. Divide by 5. And we get x equals 1. Are we done? We're looking for KL. We're looking for KL, which is 2x plus 5. So KL is 2x plus 5, so we're going to do 2 times 1, which is x, plus 5. 2 times 1 is 2, plus 5. So KL is going to equal 7. Yeah, if you kind of tried that on your own first without changing that to a 10, you might have a harder problem, but it's still the same process. It's just going to be nasty problems here, okay? All right, moving on. we have a couple more examples here. So let's get into it. All right, so we're going to draw, it says find the midpoint. We know the endpoints of PR are -2, 5, and 4, 3. Find the coordinates of the midpoint. Okay, we're going to make a drawing here, all right? We're going to make a drawing. So we're going to draw 2 lines here, or we're going to draw 2 points here and connect them. It's not going to be a perfect drawing because I can't use a straight line on here. Then we're going to put a dot right in the middle. These are congruent. We're going to put tick marks, okay? I'm going to call the first endpoint x1, y1. I'm going to call the second endpoint x2, y2. And the midpoint, we're going to call x sub m, y sub m. Okay, so these are the coordinates basically we're looking for in this, this thing here, okay? So we're going to do example 3, then you guys are going to try checkpoint 3, and then we're going to do example 4, and you guys are going to try checkpoint 4. They're basically the same formula, but example 4 is a little bit harder, and you'll see why in a second, okay? All right, so example 3, the endpoints of segment PR are -2, 5, and 4, 3. Find the coordinates of midpoint M. So we're looking for midpoint M, okay? Now, which one was that? What was the coordinates? Like in this drawing up here, in the drawing up there, what was the coordinates? We're looking for x sub m, y sub m, okay? We're looking for x sub m, y sub m. Which means if these are the endpoints, we're going to just label these. I would just call them x1, y1, and x2, y2. Okay? So now we're going to plug into the formula. So we're going to do x sub m, which equals, it's going to be x1 plus x2 all over 2. And then y sub m, the y coordinate, so we're doing the x coordinate and the y coordinate here of the midpoint. It's going to be y sub 1 plus y sub 2 all over 2. Okay, so now we just got to plug in what we know and what we're looking for here, okay? So x sub m we don't know. That's what we're looking for. We're going to keep x sub m equals, what's x sub 1? It's -2 plus, what's x sub 2? It is 4 all over 2. All right, so now we have x sub m equals, what's -2 plus 4? It is 2. And what's 2 divided by 2? It is 1. So the x coordinate of the midpoint is going to be 1. It's midpoint, what do you do? Add them together and divide by 2. How about the y coordinates? Well, we have y sub m equals, y sub 1 is what? The y coordinate of the first endpoint is 5, plus the y coordinate of the second one, y2, is 3, and we divide by 2. So we have y sub m equals, what's 5 plus 3? 8. What's 8 divided by 2? It is 4. Okay. Yeah. Okay. I'm going to actually erase this and write it a little bit better for you, just so you guys, you probably won't see me erasing anything because that's kind of how this program works. I'm going to rewrite what we just talked about. I'm going to rewrite it just a little bit better so you guys can see. I'm just going to write it a little bit more organized, okay? All right, here we go. So you won't see a lot of what I'm writing. Okay, x sub 1 plus x2 over 2, and then y sub m equals y sub 1 plus y sub 2 all over 2. So we're going to rewrite this. So x sub 1 was -2 plus 4 over 2, which equals 2 over 2, which equals 1. And over here we had 5 plus 3 all over 2, which equals 8 over 2, oops, which equals 4. So the x sub m, the x coordinate of the vertex, x sub m, y sub m, is going to equal 1, 4. Okay, so that's the coordinate of the midpoint. All right, if you had a negative or something here, you can do plus a negative, or you can just do minus. So for example, if right here it was -4, you could just do -2 minus 4, or you could do plus -4, okay? So either one would work. Okay, so that is the example for this one. Now I want you to try checkpoint 3. Try checkpoint 3, which is down here. It's this example right here. Give it a try just like we just talked about. Okay, the endpoints is CD. We know the endpoints. We're looking for the midpoint, which is x sub m, y sub m. And we're going to label our points. x1, y1, x2, y2. So we're looking for x sub m equals. So what's our x1 plus, remember it's x1, midpoint, what do? Add them together and divide by 2. And we have y sub 1 plus y sub 2 all over 2. Okay, so let's plug it in here. What are we going to get? X sub 1 is negative 8 plus x sub 2 is 2 all over 2. What's negative 8 plus 2? Negative 8 plus 2 is negative 6 over 2. And what's negative 6 divided by 2? That is negative 3. And the y sub m, the y coordinates of the midpoint, we're going to do, so y sub 1 is negative 1 plus y sub 2 is 4 all over 2. And negative 1 plus 4 is 3 over 2. Can we reduce that or not? We actually can't. It's 3 over 2. So what's the coordinates of this midpoint over here? We're going to do x sub m, y sub m equals negative 3 and 3/2. Keep it as 3/2, okay? All right, sounds good. Okay, so that's how you do it if you know the endpoints. Now, what are we looking for here? Let's read this next one. It says the midpoint of AC is M is 3, 4. One endpoint A is 1, 6. Find the coordinates of endpoint C. Okay, this one's a little bit different. This one's a little bit different here, okay? We're looking for the coordinates of what? The endpoint. So I'm going to call this one, I'm going to call this x1, y1. And remember, the endpoints are either x1, y1 or x2, y2. I like to do x1, y1 for this. You'll see why in a second, okay? What's m? M is 3, 4. Is that x2, y2 or xm, ym? This is xm, ym, which means this has to be x2, y2. Okay, we're going to do a vertical representation of it this time. So we're going to do x sub m. Remember, it's midpoint. What do? Add them together and divide by 2. Same thing over here. Okay, so we're going to plug in what we know here. Well, this one's a little bit different. And why is it different? Let's see. We actually know xm and ym is what? Or it should be an m here. Xm, ym, we know xm is what? It is 3. We don't know x1. We're looking for that. But x2 is 1 all over 2. So we're using the same formula. We're looking for something a little bit different here, okay? And then what was ym? Ym was 4 equals, then y1 we're looking for, plus y2, which was 6 all over 2. Now I want to solve for x1 and y1. How do I do that? Well, I need to multiply. I like the fraction bust first. So I'm going to multiply both sides by 2. 2 times 3 is what? 6. So I get 6 equals x1 plus 1. Now what do I do? Subtract 1. So I get x1 equals 6 minus 1 is 5. Over here, times 2 again, fraction bust. I get 8 equals y1 plus 6. Subtract 6 from both sides. So I get y1 equals 2. So our answer for this is going to be x1, y1 equals 5, 2. So this will be the coordinates of one of the endpoints rather than the midpoint, okay? All right, why don't you guys go ahead and try this example down here, checkpoint 4. I'll leave it zoomed out so you can see all of these. And so give it a try, see how you do. All right, the midpoint is 5, negative 6. So we're going to call that x1y, or actually, sorry, xm, ym. And the endpoint is negative 3, 7. I'm going to call that x2, y2. Find the coordinates of endpoint z. I'm going to call that x1, y1. So we're going to plug into the formula. Midpoint, what do? Add them together and divide by 2. And ym equals y sub 1 plus y sub 2 over 2. So we're going to plug in what we know here. We know the x sub m is 5. x1 we don't know, plus x2. Okay, here's a little bit weird. Okay, it's plus negative 3. What I'm going to do instead of plus negative 3 is I'm going to write minus 3. Okay, it's the same thing all over 2. Y sub m is negative 6. equals y sub 1 plus 7 all over 2. How do we solve for x1 and y1 now? We're going to multiply by 2 on both sides. So we get 10 equals x sub 1 minus 3. Add 3 to both sides. 13 equals x sub 1. And over here, multiply by 2 on both sides. So we get negative 12 equals y sub 1 plus 7. Subtract 7. So negative 19 equals y sub 1. So our x1, y1 equals 13, negative 19. So that's the coordinates of one of the endpoints given the midpoint and the other endpoint. Okay, sounds good. That is it for day 1. We're going to move into day 2 right now. It's up in the top right over here. All right. Okay, let's get into day 2, which is going to be talking about distance formula. Okay, so distance formula, we have this really kind of like long and complicated formula. Okay, so AB, I'm gonna get this and put distance equals the square root of x2 minus x1 quantity squared plus the quantity of y2 minus y1 quantity squared. Okay? So we have a formula for this. We have a song for this. I'll try to post it on Canvas if I'm able to, or our learning management system. But yeah, so we have a formula for this. It's to the tune of Hot Cross Buns, and I'm a terrible singer, but I'm gonna sing it here, okay? So it's distance formula, square root, x2 minus x1 squared plus y2 minus y1 squared, x2 minus x1 squared plus y2 minus y1 squared, distance formula. Okay? We'll be singing that in class too, and you'll hopefully do better than I did, but it's just to kind of get you the idea down here, okay? All right. Distance can be referred to as distance or length. Distance or length, okay? Basically, it's how far it is between 2 points, okay? It's how far it is between 2 points. All right, we're going to do example 1, then you guys are going to try checkpoint 1, okay? Let me actually look at that, see which one's a little bit easier, though. Oh, we got some square root stuff going on here. Okay. Yeah, we'll do example 1 first together. Okay, so what is the approximate length of RT with endpoints 3, 2, and negative 4, 3? So all we need to do first is label our points like we would with the slope formula. We go x1, y1, and x2, y2. Okay, so we're going to plug into distance formula. Square root x2 minus x1 squared plus y2 minus y1 squared. All right, so we're going to do this. So distance, or RT, I guess, we'll put equals RT here. Okay, so we're going to do distance equals square root. So what was x2? We're just going to plug into the formula. That's why I sung the song, is because it's important to know how the formula. And plugging it in is not too bad, but this is why it's important, okay? So x2 minus x1 squared, what's x2? We have negative 4 minus x1 is 3 squared, per close parentheses squared, plus y2, which is 3, minus 2, which is y1 squared. Now we're going to simplify this. What's negative 4 minus 3? Is negative 7, quantity squared. Make sure you use parentheses here. Distance can never be negative, and if you don't keep the parentheses, it could goof you up. What's 3 minus 2? It is 1 squared. All right, what's negative 7 squared? Is it positive 49 or negative 49? It is positive 49. So we have 49 plus 1 squared is 1. So we get distance equals square root of 50. Okay? You can plug it into your calculator if you want to get an approximation, but I'm going to simplify this exactly to kind of review how to simplify radicals. What's a perfect square that goes into 50? Yeah, 25. So I'm going to write square root of 25 times square root of 2. And what's the square root of 25? It is 5. So 5 square root of 2 is the exact answer. But the approximation, if you just do square root of 50 on your calculator, RT is going to be approximately 7.07. And that's going to be the approximation. If you have to do any rounding on your calculator, it's going to be less accurate. It's not going to be exact. So that's why I like exact answers too. Okay, why don't you guys go ahead and I'll leave it zoomed out here. Why don't you guys try checkpoint 2 now? See how you do. All right, what is the approximate length of GH? This is what we're looking for, and it is D with endpoints -5, 1, or 5, -1, and -3, 6. We got x1, y1, and x2, y2. So we're going to plug in distance formula. Square root x2 minus x1 squared plus y2 minus y1 squared. All right, let's plug in what we know now. What is x2? x2 is -3 minus x1, which is 5. Hey, I have a question for you. If we were to have like -5 here, what would you do instead? You wouldn't do -3 minus 5. You would do -3. It'd be minus -5, which two negatives make a what? Makes a positive. So you got to be careful with that. It's always minus, but if it's a minus and negative, it becomes plus a positive, okay? Then we got y2 minus y1 squared. And here we go. That's what we're just talking about. So we have 6. I'm going to write minus -1, right, which is y1. Okay, let's go ahead and simplify this some more. So we got -3 minus 5, which is -8 squared, plus over here, minus negative, chop, chop. We got 6 plus 1 squared. All right, so we got D equals square root of, we have -8 squared is 64, plus 7 squared. Square root of 64 plus 7 squared is 49. So we got distance equals square root of 113. And you can't simplify that, I don't believe, because I think it's a prime number. And then you're going to do approximately 10.6 you plug it into your calculator. Okay? Make sure you talk to me in class if you need to figure out how to plug it into your calculator. Okay? All right, I think this, I'll actually write the buttons here. So if we do, we do the second button. We do x squared. It's only for the TI 30, Texas Instruments 30 that's going to work. Second x squared, then you plug in 1, 1, 3, and then you would hit close parentheses, actually. Close parentheses, and then you would hit equals. Okay, so that's kind of how you'd plug it into your calculator, all right? This is a parentheses right here, okay? All right, that should be it for today. Thanks for watching. Have a great day, and we'll talk soon.